So the session today is, and the panel here are about discussing what are the applications of NVMe oF fabrics, of its different varieties, and how do we leverage them, and what solutions are we seeing that are emerging in the industry. We also want to know what to expect from this direction and see where we're heading. And we also want to learn from early adopters and what sort of implementations that they're both bringing to the industry and also leveraging. So first off, we're going to start with Marcus.
Well, thanks a lot, Saji. And so what I will start with is really give you a perspective based on the interaction we have with our customers from the Brocade storage networking team within Broadcom, as well as working with our partners, which are the traditional enterprise storage vendors. And so the first thing we look at when we look at, what is the best solution for running NVMe over Fabric is what is the fabric that you're going to select. Of course, depending on what the customer already has, they will be inclined to go one way or another in their selection. But secondly, if you look at it from an application perspective, some applications have more freedom than others in the selection of their fabric. And what I've tried to do on this slide here, and I apologize, it's probably extremely hard to read from back down there, but is to say, if you look at traditional enterprise applications, from the owner of the application, there's very little freedom to actually do any kind of modification to the storage stack of the application. It's sort of given, and the application really needs high reliability of the network, low latency obviously for performance. Performance should be deterministic, and there is a need for some level of scale. If we then move on to the middle column there, which is hyperscale applications, well, if you think about it, hyperscale applications are often owned by someone who have complete control of the application and the full stack, which means that they can handle things at different layers within the storage stack. And therefore, the needs or requirements to the network can be eased in some ways or another. And so what I put on here is that reliability of the network may not have to be as high because you can handle things in the application layer in a different way when you own the whole application end to end. Low latency is obviously still a very strong requirement. Deterministic performance, well, depending on the application, you can probably live with that once in a while performance is not necessarily always at your full baseline. And then when it comes to scale needs, well, can you stay within a rack architecture, or do you really need to go across racks for storage traffic? Those are things that you can often handle in a different way when you own the application end to end, and it's truly built as a hyperscale application. Then as we look forward to, I would say, newer applications around analytics, machine learning, AI, well, often what we've seen with these analytics application is that you put storage directly into the servers and then basically distributed your workload so it was localized to where the storage and the data was. As we see these applications coming closer to be how do you say, standard off the shelf from an enterprise perspective, I think what we will see is a shift where you go back to shared storage architecture. With NVMe, there is, the means or the performance available to be able to do that. And a lot of the data that the enterprise want to have as the foundation for the analytics is already in their enterprise applications. So not having to basically redistribute it and have a lot of these data ingest challenges is something that can be solved with going back to a shared storage model. And here, the fabric requirements look a lot like the ones that we look at from a pure enterprise perspective. If we look a little bit different at the problem is, okay, so the areas of improvement performance improvement with NVMe over fabrics, where can we expect these to come from? Well, I'm sure you're all very well aware of the more efficient stack that we have with NVMe compared to SCSI, and therefore the improvement we get on the server side, and the same thing on the front end of the array side that enables NVMe over fabrics access to the array. Then internally in the array, obviously the SSD drives can be attached with NVMe or SAS or SATA, but with NVMe, you clearly get the benefits of NVMe, obviously. But what about the storage controller path, or how do you say, the storage services within the array? There, I think what we will see and what we need to see to get full benefit and return of investment with NVMe is that the array vendors will have to change their array architectures so you can either get faster applied storage services or maybe even have fast paths through the storage controller for applications that you want to have the absolute lowest latency. And so from a fabric perspective, there's really no difference whether you're transporting NVMe or SCSI for that sake, right? That should be handled more or less the same way. The question is, how well can you handle if there are any challenges or issues with congestion, oversubscription? I'm going to talk a little bit more about that in 2 slides, I think. So if we look at the adoption, so this is a slide that I basically took out of a webinar we did together with NetApp and IBM in, I think it was May timeframe, because these were the first 2 in the market to offer NVMe over Fibre Channel. And this one is particularly from NetApp, where they show, okay, across different industries, who were the adopters and why did they look to NVMe? Well, they obviously looked at their business critical applications, your usual suspects in the enterprise, which are transactional database systems, and they wanted to accelerate those. Secondly, future-proofing was very high on the list of objectives for why they wanted to, kick the tires around NVMe over fabrics. And following very closely after is really this objective of being able to get more information out of their data, get close to real-time type of analytics, maybe even AI or machine learning going forward for their enterprise data. If we look a little bit more towards the future of, okay, what's the impact of NVMe over fabrics? How will that change how storage is consumed in the enterprise? Well, what I tried to show or illustrate with this diagram here is what is the impact on the networking side as we get faster and faster devices. What it shows here is the transition from spinning media arrays to all-flash arrays to NVMe arrays. And what you see is that the idle times on the network decrease dramatically as we go an order of magnitude performance up or better, you could say, with the next generation devices. And so what we saw already with all-flash arrays in the enterprise is that when you have a mismatch between maybe a little bit older server and a new array, when it does a read, it gets so much data so fast that the server cannot no longer process it, or it cannot process it as fast as it gets the data from the storage array. And the result of that is you get congestion or backup in your fabric. Well, with NVMe, we expect that this is going to be exaggerated even more, and a lot of our tests actually already show this. And so having a network that's able to both monitor for this and then automatically mitigate this is extremely crucial as we look towards the future of NVMe over fabrics. The second thing is around how the storage architecture changes. I talked a little bit about it on the array side. Obviously, we will have arrays that support both NVMe and SCSI, probably at some point in time, arrays that, well, who knows, only support NVMe. But I think I'm a strong believer that from a vendor perspective, if you're selling an array into the enterprise, if you don't have support for NVMe, on the host side, by the time of next year, I think a lot of customers will probably not evaluate your array. At least that's what we're seeing when we talk with our customers about the storage networking side. They're very focused about being future-proofed for NVMe. I'm also trying to illustrate there that for HCI or software-defined storage implementations, I think I have some expectations, at least, around how we're going to see this market really take off with NVMe over Fabrics. And then finally, the application architecture changes. I'm sure you're all familiar with the multi-queue capabilities in the NVMe protocol, and we haven't really seen any applications taking advantage of that yet. But as soon as that happens, I think we're going to see a completely different adoption rate of NVMe over Fabrics or NVMe in general. First of all, transactional systems, they can be accelerated if you can have multi-queues, but also if you look at our hypervisor environment, think about it, if every virtual CPU has its own I/O queue instead of sharing it with all the other virtual CPUs or VMs on that hypervisor, what that could mean to the scalability and efficiency of your compute environment. And finally, an architecture like this really lends itself very well to what we talked about around analytics, machine learning, and AI architectures. And so with that, I will hand it over.
Bryan. Okay. Me next? Great, thank you. It works. Awesome. Okay, so again, I'm Bryan Cowger from Kazan Networks. I wanted to talk about our perspective for the use cases of NVMe over Fabric. So I think that the industry is really contemplating NVMe oF for really three primary use cases, and many of you may well be aware of this. So the first is the relationship between a RAID or a NAS head and its expansion shelves. That's been traditionally fiber channel and then SAS, and now I think as a SAS replacement. Certainly if you're going to be moving those expansion shelves, the type of storage in there to NVMe, it makes an awful lot of sense to be running NVMe over Fabrics to that. A little bit more expandable from not so much as an addressing space, but certainly from a distance space beyond what you can do with SAS. The second use case is a replacement for SANs. So again, in the use of NVMe drives, in the quest for more performance, let's replace some of these older HDD and SCSI-based SAN technologies like Fiber Channel and iSCSI with a nice, lightweight, very fast infrastructure based on NVMe over Fabrics. The third category is kind of taking today's DAS model, which is employed by a lot of hyperscalers today, and coming up with something called scalable DAS. So this is where we take these SSDs out of the application server itself, turn those servers into stateless servers that are just there to run applications. They have no storage. Put these SSDs into a pool, insert a fabric in there so that the application can still get to that pool of storage. And then this really becomes what everybody here is calling composable infrastructure. It's common theme here at the show. And so it's really this third case that I want to talk about here. I think the first two are fairly self-evident, but the third one we think is going to be the long-term real killer app for NVMe over Fabrics. So why should anything change in today's DAS model? Well, let's look at how much is being spent on hyperscale hardware build-out here. And you can see from this chart, a little bit dated, but certainly the trend is obvious here. Roughly $100 billion plus and growing spent worldwide by hyperscalers on hardware build-out. So if we do some rough macro math there, let's just assume that 50% of that is buying land and building buildings and putting in HVAC and putting in UPSs. The other half spent on compute, networking, and storage resources. So that's on the order of $50 billion spent there. and then make another gross assumption, maybe 25% of that is spent on storage, which is actually pretty close to reasonable, I think. So what's that, 12, 13, 14 billion dollars spent by these guys on storage. Some very low-hanging fruit on saving a huge amount of money is to try to figure out how we can spend a little bit less on that storage and still get the job done. So if we look at today's DAS model, I can't speak for all the hyperscalers, but I believe that many, if not most of them, are still using this DAS model. Let's look at that and figure out why it can be challenging, and then we'll look for opportunities. So it's very simple. You have a CPU with some number of cores there, and then you need to decide how much storage am I going to add into that server in this direct attach storage mode. So you pick some number of, used to be HDDs, now it's increasingly turning to SSDs. The challenges that brings is it forces you to make that upfront decision when you're building out your data center. You have to pick that compute to storage ratio that you think will serve you well over time for today's applications and whatever's coming down the road that you haven't anticipated yet. So because it's so hard to figure out what your compute to storage ratio requirements are going to be down the road, you typically would over provision the storage just so it can be there for that worst case application. And with HDDs, that wasn't a big deal. These guys were paying $50, $60 for an HDD, and so they'd throw a bunch of them in there and use some portion of them. With the move to SSDs, that's a more expensive kind of mistake to make, right? You have to try to get a little bit closer and spend not leave a whole bunch of extra SSDs in these servers that aren't generally being used. So if we look at this and look at a typical cloud services provider, they've got to run all kinds of different customer applications on this hardware. And so if we just do a very simple model here where we've got 3 applications, each one needs variable amounts of storage. So app A needs 1, app B needs 2, app 3 needs 3. In this simple model, you can see that 6 of these 12 drives are being utilized. 6 are not utilized, and this is a real problem. The industry calls it dark flash. It's storage sitting there waiting for some future application need to come in there and require its use. So the net utilization in this very simple model, 50%, I think the industry generally agrees that in a cloud services model where you have lots of different applications running, that number is in that 40 to 50% range. So that's a lot of dark flash sitting out there. So if we look at disaggregating it, and again, these are not new terms, so I'm sorry if I'm repeating a bunch of stuff for people, but it's very simple. We just take the CPUs, we put them in a pool, we take all the SSDs, we create a pool out of them, and then we allow the applications on those CPUs to go in and connect to whatever storage that they need. So we end up with this idea of this composable data center where app A goes and grabs his 1 SSD, app B gets his 2, and app C gets his 3. That's our 6 utilized SSDs, and now we have the other 6 underutilized SSDs as spares waiting out there to be connected. So the breakthrough here, the magic sort of that happens, is that you quickly realize, well, I don't need 6 spare SSDs out there. What if I eliminate, say, 4 of them? I've got a couple out there for future expansion needs, for spares in case we get some failures. This is the huge CapEx savings that you get. So if you're spending, what did we say, $12 billion on SSDs, and you can get away with a lot less than that, these are not insignificant amounts of dollars to be saved by going to this composable data center infrastructure. You've minimized the dark flash. You're buying storage only as you need. It's very easy to roll in more racks of storage as you need it, plug it in, and it's there in that pool ready to expand to as needed. And the OpEx savings comes because you're only powering the SSDs that you need. You're not powering all that dark flash. Okay, so that's the idea of the composable infrastructure. The benefits, huge TCO savings, a vastly more flexible infrastructure. In our simple model, the apps only needed a handful of SSDs, but there's no reason that an app couldn't connect to 1,000 SSDs in this model if it needed, or a tenth of an SSD in this model if it needed. You get that flexibility to pin the right amount of storage to each application and boost that storage utilization. And another side benefit that we didn't talk about, you get to upgrade this hardware on its own intrinsic life cycle. Processors, maybe you want to update those every 2 years with the Intel or AMD refreshes. But you might want to get 5 years out of your SSDs. If you can have them in separate boxes, it's a lot easier to do those upgrades without having to open up boxes and actually start swapping stuff out. So clearly some benefits, but, and there's always a but, at what cost to performance? Okay, it should be obvious that we had these SSDs plugged directly into the application server before. It's only a PCI bus hop away to get to that storage. Clearly, very good expectations for performance out of those SSDs. Now we've separated them out. Maybe they're in different racks or even different rows within the data center. We've got this Ethernet fabric in between them. So let's talk about that. So a simple model of this disaggregation looks like this. We've got servers on the left, we've got an Ethernet fabric in the middle, and then we've got these pools of SSDs over on the right. The way these typically are deployed is that they're in the so-called JBOF, just a bunch of flash, or an Ethernet attached bunch of flash, or a fabric attached bunch of flash, pretty much all synonymous. The performance of the fabric is, the performance impact of that fabric is minimal, typically fractions of microseconds of additional latency there. Same thing with that fan-out switch. It's a PCI Express switch often. It's adding some number of nanoseconds to the overall latency. The SSDs are the common theme here in terms of latency. Whatever latency they exhibit over there would have been the same latency that they exist in that server. So the last component is this fabric to PCI Express bridge that has to speak the NVMe over Fabrics protocol, RDMA, TCP, whatever, over across this fabric, and then convert that to just the regular old NVMe traffic that these SSDs want to speak. So let's look at the latency implications of that bridging function there at the edge of that JBOF. So there's lots of different ways you can do that bridging function. There are 5 or 6 at least different solutions out there, many offered by my colleagues here at the table today. Some of them are more software-based. Maybe you've got a bunch of processors in there running firmware. Some of them, like ours, are more hardware-based. So I want to offer this hardware-based solution up as a way to examine what's the optimal performance that we potentially could get from this bridging function. So with this hardware-based architecture, that means that firmware is really minimized to only housekeeping and management tasks. It's not involved in I/O paths. Coming from the Ethernet fabric connection on the inside of the bridge up to the PCI root complex that talks to the drives. Okay, we have a hardware-based path here. We have a hardware-based outbound path, and as I mentioned, firmware relegated to just the management task. So with this hardware path going through the chip and literally some number of hundreds of nanoseconds going through that, the performance you can get is significant. So let me skip through some of these in the interest of time here. What we're able to show at the show today in our booth, if you want to stop by, is from a 2U24 drive JBOF. We're able to pull 16.3 million IOPS out of that and almost 70 gigabytes worth of bandwidth. So you can see that you can move this stuff on the other side of a fabric and not necessarily be bottlenecked by anything. So IOPS bandwidth, okay, that's great. You might be asking, okay, what about latency now? Here's some specific comparisons to drives when they're in the DAS mode and when they're in the fabrics mode. You can see that basically you can get to that drive just as fast, you can get just as much performance out of that drive in either mode. Same thing for Octane. Let's talk about Octane, one of the fastest drives out there here. You can see that this is one of the attributes of Optane where it really shines is the write performance. You can see the very balanced write versus read performance out of this Optane drive. And then same thing with the bandwidth side. You can basically get all of the DAS performance out of a drive on the other side of an NVMe over Fabrics infrastructure. But let's talk about latency, because that's the one that intuitively, now we're going across the data center getting to this drive. How is that going to be impacted here? And this is the final point that I'll go through. So here we're looking at the average IO latency of an Optane drive in DAS mode versus remote mode. You can see that if we look at the single outstanding command at the bottom left here, that there is in fact a penalty that NVMe over Fabrics infrastructure costs you about 5 microseconds of additional latency. And with an Optane that has a native read latency of only about 9 microseconds, that's pretty significant. But notice that as we start to load up that Optane drive with more and more commands, the blue DAS line disappears behind the red line, and there's essentially no discernible latency difference between that remote attached Optane and the local Optane. And here's another way to look at that. It's the incremental latency to get to that remote Optane versus the local Optane, mapped across various queue depths and the various queues that you may be feeding IOs to that drive with. So the worst case is that back left column there when we just have one queue and one entry. That's that 5 microseconds of penalty. But I think anybody who uses these in real applications, nobody's running a drive with a single queue entry per queue or even a single queue. So really, in a real use case where you've got multiple queues going into that drive and multiple entries per queue, the delta drops to essentially 0. It's within 0.5% of performance to reach that Optane drive in a remote mode versus a local mode. And keep in mind, from a latency perspective, Optane is the worst case. If you're going to a NAND-based drive, no problem. Okay, so summary and takeaways, there's lots of options now hitting the market to enable composable infrastructure. We've been talking about it here at this show for 3 years. I think the time is now upon us. We see hardware products getting into production. We see systems getting into production. I'm feeling very good that the first half of next year is going to start to see some real deployments. There's some very low cost, low power options to enable that remote pooling of storage. And as we just talked about, there's essentially no loss in performance compared to DAS. That is possible. IOPS bandwidth and even latency can be equivalent, and then you enjoy all that storage utilization improvements that you're looking for. That's it for me. Thanks.
So storage disaggregation. Bryan has talked about it in his session. Storage disaggregation concept has been around for a while, or composable storage, also called. The concept has been around for a while, but we haven't seen the hyperscalers adopt it or implement it. Most of them have not touched it until recently, where they've been looking at it. The motivation behind it is clear. The ability to scale storage without scaling compute and scaling compute without scaling storage. The cost savings in CapEx and OpEx, the lower of MTBF, all have great benefits that have not been happening at the hyperscalers. So what's the problem? Why haven't they been adopting it? NVMe over Fabrics has been here, and it shows all the benefits that are needed to have remote storage as local with the same bandwidth and maybe almost the same latency. But still, the disaggregation was not happening at the hyperscalers. So again, what is the problem? So what we see today is that the hyperscalers are finding it hard to adopt the software on their side to go and implement NVMe over Fabrics. It requires changes, requires upgrades of kernels. It maybe if you're a Windows or a VMware infrastructure, it's harder to implement because the infrastructure doesn't even have NVMe over Fabrics drivers. So the software stack, maybe, even if you're upgrading the kernel, you need to install RDMA drivers. It's cumbersome. It's hard to manage. So we see the software as a barrier to entry. What's the solution? We call the solution NVMe Snap. NVMe Snap is based on a smart adapter, a PCI adapter, that implements an NVMe interface on the PCI. It's exposing itself as a local storage. The host sees local storage using standard NVMe drivers, and the adapter is implementing the NVMe over fabrics inside. It's implementing the connection to the remote storage behind the scenes. The host doesn't even know that the storage is not local. Hence, we are implementing a zero software change on the host while doing NVMe over fabrics on the fabric. So what is it doing behind the scenes? So on the left, you've got the standard disk drive, local disk drive that is not over-provisioned. It's not utilized correctly. And on the right, you've got Snap replacing the local storage, meaning the host is left with no physical storage at all. The NVMe Snap implements that NVMe controller interface on the physical function, and the host is unaware of any change. Behind the scenes, that smart adapter can implement NVMe over fabrics to a JBOF, or it could implement any type of storage solution. It could even go with a proprietary solution on the wire. So overall, Snap is OS agnostic because it's using the same NVMe driver. It's hardware accelerated. It's able to do NVMe to NVMe over fabrics directly in hardware with no software at all. And it's also bootable. You can actually boot the host from NVMe Snap as if it's local storage. There's also SRIOV. NVMe SRIOV is pretty new. It's a benefit to the hypervisor, where today there's a big bottleneck on I/O on the hypervisor for the VMs. Exposing NVMe SRIOV to a VM could potentially give it bandwidth, unlimited bandwidth as the bandwidth of the network. So disaggregation at the hyperscalers means that on the left you have local storage that's unused, and on the right you've got NVMe Snap replacing that. So the whole benefit is actually allowing to grow the compute without growing storage, and growing storage without growing compute. That saves a lot of money and improves the MTBF. And it's using that infrastructure of NVMe over fabrics, providing that local use and feel. So what else is inside the the NVMe Snap? We are providing the SPDK bundle package. It's an open source storage package for those of you who are not familiar with it. SPDK has its advantages. It's a whole infrastructure that allows our partners to build their solutions on top of it. It allows to implement a proprietary protocol or use the ones that are already existing, such as NVMe over TCP or any other Linux POSIX driver. The benefit here is that customers can implement their own business logic on their storage solution, their own management interface to the storage backend, and allow a full orchestration of the solution end to end. The overall NVMe Snap solution is trying to bring in what is being delayed by the adoption of NVMe over fabrics in the market. It resolves the NVMe over fabrics drivers issue, it resolves the upgrade issues, and it allows practically to implement any type of solution.
That's it. All right, thank you, Erez. Next up is Nishant from Marvell.
Okay, hello everyone. My name is Nishant Lodha. I work for Marvell, do product marketing for Ethernet NICs and fiber channel HPAs. I spend a lot of time talking to end customers, and a lot of those conversations recently have been around NVMe or fabrics. What I want to do here in the next few slides is give you a little bit of my perspective of what I see out there, what do customers like, what they do not like, and how the customers are going about in their thought process as they embrace NVMe or fabrics. So first off, when I talk to customers, and often get asked the question, what is the right approach to choosing a fabric to help me scale out NVMe all across the data center? Should I choose fiber channel? Should I use Ethernet? Should I use RDMA? Should I use TCP? And why don't you give me your advice, Nishant? And I say, I cannot. I can guide you in that direction. And these are the following things I tell them. Hey, Mr. Customer, when you're choosing a fabric for your network, for NVMe, make similar choices as if you were choosing a fabric for your next suit, right? It depends on what kind of expectation you have from your fabric. And that is not just about performance of that fabric. It is also about your culture within the company, your use case, right? You will see a lot of people coming up and talking to you guys, or you hearing outside in the industry, Fabric XYZ has the lowest latency, or this 5 microseconds, 10 microseconds, 20 microseconds. Don't be influenced by simply a performance metric. Look at what organization skills you have within your company. If your company has a lot of investments in fiber channel, is comfortable with fiber channel, you have the right skill sets, maybe taking fiber channel forward with FCNVMe may be a great choice for you guys, right? If you have a lot of networking expertise within your environment, within your networking group, and can deliver a lossless network, maybe NVMe over RDMA is a good choice, right? And so far and so forth, right? And also, it also depends on a lot of use cases. And so if you double click on the use cases piece itself, and this is my view of the world, right? And I'll compare these three so-called boxes, starting with NVMe over RDMA, which is primarily today NVMe over Rocky. But I guide my customers that if you are trying to take storage and putting it farther away, and you're looking at applications, primarily high intensity databases, HPC applications, deep learning workloads, things like that, and you have a good grasp on your network and can manage and deliver a lossless network, NVMe over Rocky is a great choice. You will get the right performance because you have the right skill set and expertise within the company to go deploy it. From enterprise applications, for many, many years, customers have trusted fiber channel to transport their data all across the wire. There's nothing wrong. There's no need to shift your strategies away from fiber channel. Fiber channel is evolving to do FCNVMe. That will take you forward. So a lot of enterprise applications, business critical applications that relied on fiber channel, I recommend that they continue to rely on fiber channel or its next avatar, FCNVMe. And there comes the rest of the crew, right? The all-encompassing bucket, which is NVMe over TCP, right? If you can tolerate a little bit higher latency, a slightly lower IOPS performance, maybe, and your company does not have the skill set to deploy a lossless network, cannot invest so much in a fiber channel network, NVMe over TCP is a great choice. It will help you, every single server within your data center, connect to this honking new storage array or a eBOF that you just obtained, and not create any islands within your data center. So in short, just no one size fits all. And I'll segregate here and give you a small example. I think yesterday morning there was a talk about NVMe over fabrics, and that talk was about the success stories about how NVMe over RDMA was deployed at this one customer, right? Beyond all the vendor talk, which is of less interest, the customer there was LinkedIn, right? And there was a lady from LinkedIn who talked about their experiences in deploying NVMe over Rocky. And she was pretty serious when she came up on the stage that I'm going to tell you a 3-step technique by which you can be successful in deploying NVMe over Rocky. Step 1 is when you talk to your network guys and tell them that you need a lossless network, make sure that they are sitting on a chair so that they don't fall off. Number 2, make sure that you have a lot of beers, candies, dinners to take them out because you will be asking them for a lot of favors. And number three, it's possible that you may have to write additional checks, maybe for a different kind of skill set or training for your network crew. So, take that with perspective. That is the end user's kind of experience in deploying NVMe over RDMA, and there could be complexity. So no one size fits all. You have the right expertise to deploy Rocky. Please go ahead and do that. You'll get the bang for the buck. Your investments in fiber channel, take them forward, right? They'll take your infrastructure, your business critical applications forward. If not, let's all do NVMe or TCP. So here are some kind of, in the next few slides, I'll just talk about a few new and emerging use cases that we see out there. And everybody in the room, hopefully, is familiar with a hyper-converged infrastructure, or HCI. And there are many different solutions from various different vendors, both software-only solutions as well as hardware solutions. Popular names are VMware vSAN, Nutanix, HCI, and things like that. What is happening, what is the biggest challenge with the hyper-converged infrastructure is that if the customer needs to scale their storage, they need to scale the compute along with it, because it is a set of nodes, each one with their own local disk and drives and NVMe. And if you want more storage, you need to put another server in the mix. And hence, even if you don't need compute, you're forced to buy more compute. Right? External storage, as everybody in the panel kind of talked about, here has tremendous value. This dark flash, all of that stuff, right? This is the marriage of the two, where you can bring external storage in the form of an eBOF and plug it into a hyper-converged environment, right? And this is future-looking stuff that hopefully you guys will see shortly within this year or early next year in terms of solutions. But what happens here is that you can take a eBOF, plug it into a hyperconverged infrastructure, and all of that storage can then be consumed by this software-defined storage infrastructure and presented to you as part of a hyperconverged infrastructure. It's truly the marriage of the two. And the technology that, among many other choices, one of the technologies that can be used here is NVMe oF Fabrics, where you use NVMe oF Fabrics to connect to external eBOF and then consume it within your hyperconverged infrastructure. Pretty interesting stuff here. Next off is deep learning. A lot of you guys are perhaps familiar with the kind of machine learning model. There's a lot of kind of GPUs and a lot of compute capabilities required in order to train models. A lot of big data sets are required. And the most popular reference architecture that is used for these deep learning kind of environments is defined by NVIDIA, and they're called the DGX1 and the DGX2 reference architectures. And if you pop open one of these reference architectures, you will see that each one of these compute nodes are pretty heavy on local NVMe drives, because all the models, all the weights and all that needs to be stored, distributed and things like that, and you need access to high-speed storage. Some of the customers are, instead of having captive NVMe in each one of these deep learning nodes, they are putting up shared pools of NVMe out there and connecting using NVMe over Fabrics, because NVMe over Fabrics, especially if you use protocols like RDMA, they'll allow you to deliver you near native performance. So you can still train your models at pretty much the same speed, but you don't need to have a lot of captive NVMe inside the server. So even emerging technologies like deep learning are already beginning to embrace NVMe over Fabrics. Next off is another use case here, and that's more kind of highly transaction OLTP kind of centric applications. Especially look at Web 2.0 kind of applications. And see, one thing you have to, if you double click on Web 2.0 kind of applications and look at that, there is a lot of requesters coming into a Web 2.0 application, and each one of these requesters need to be served in a timely fashion, right? So when people talk to you about latencies about their NVMe or Fabric stack, typically the numbers that's being talked about are average latency numbers. I don't want average person in my team, and you don't want an average number to influence you in making a decision. So the right number to ask anybody claiming latency numbers is that, why don't you show me your full stack of latency? Why don't you show me what's your tail latency? Tail latency, as you see towards the end of this chart, is what the last 10% of those IOs take time to complete. If you just take a second and graze at this chart, and you can pick per se any kind of line in there, what you see is that, let's say this is 100 I/O operations. Some I/O operations complete very quickly, which is towards the very left of this chart, and some I/O operations take maybe 3 times more time to complete. So it's very important to understand the value in characterizing tail latency of different kind of NVMe over fabrics, because especially for Web 2.2 applications that serve a lot of clients, it is extremely important to understand what your tail latency is for fabrics. And here is a quick comparison between a couple of different fabrics. The very bottom of the row, the grayish color, is NVMe over RDMA, in this case NVMe over Rocky V2. And you see this line is pretty flat, right? And only towards the very end, you see that there is slightly higher tail latency. That's for a lot of these. So if you have highly tail latency sensitive applications, NVMe over Rocky is a great choice. Let's look at the very top bar, the light blue color one. That is software TCP. Now, I think NVMe over TCP is a hotly talked about topic all around last year's FMS and this year too. NVMe over TCP is a great technology. You can take any NIC or any server which has older 1 gig, 10 gig adapter and make it capable of doing NVMe over TCP. No longer create islands in your data center. But if you do NVMe over TCP simply on a software, that means do all the protocol processing using the cycles of your compute, there will be some downside. And that downside, what you see is in the tail latency, because you're leveraging the TCP IP stack, which sits within the operating system and which has huge amount of inefficiencies, taking that tail latency all the way up. Well, there are options within the industry where you can offload NVMe over TCP down to a device. It could be a NIC or any other specialized kind of application. And what you do is that you get a little bit of best of both worlds. You get the simplicity of NVMe over TCP, and you get tail latency, which is highly manageable. So I think in short, and that was my last. In short, there's a couple of things to kind of remember. When you're making a choice about fabrics, look at not just performance. Look at what are you comfortable with, what is your customers comfortable with, what is the skill set, what is the applications. There are choices all around. There is for the very low latency, excellent network skill set customers, there's RDMA, there's fiber channel for people who have investments in fiber channel, and then there is NVMe over TCP. It's probably like this chart shows, it's always a good idea to see if TCP can be offloaded so you can get a little bit of best of both worlds. And that is where everybody claps. And please come up to the mic and ask any questions.
All right, thank you for all our speakers. This is indeed time for questions. We have a mic here in case there are any. All right, so I'll start with a question. So you can take turns, panelists. This session was all around fabrics and the network and the speed. But in terms of the solution, how do you see your products utilized as, for enterprise and for cloud? Where do you see your products fit within a storage system? Who wants to start?
So, at Mellanox, we build end-to-end systems, meaning we provide the infrastructure for the NICs, the cables, the switches on the way, if it's InfiniBand or if it's Ethernet. Our storage story is an end-to-end story. We are working with the storage vendors in the industry to build the target solutions, if it's the front end or the back end solutions. But there's much value when you're going with NVMe Fabrics to an end-to-end story, implementing Rocky, as was stated here, as sometimes scary for some of the IT managers. So we do see value in the end-to-end story where everything fits together quite easily.
Yeah, so let me add from a Broadcom perspective, obviously we make products that support NVMe over fabrics for both Ethernet and fiber channel. If we look at what's happening in the enterprise today is we've seen implementations as, I would say, proof of concepts and early implementations on fiber channel, not really on Ethernet yet in the enterprise. And part of that is, the enterprise is very conservative when it comes to making changes to their storage network and to, their business critical applications. But with fiber channel, they can basically transition. They don't have to make any changes on the network as long as the adapters are of current generations that have been out for, a couple of years. Then they can basically, with an array that supports NVMe over Fabric, start using it. And that's what we've seen happen. I will add to that the laggers in this whole picture, from an enterprise perspective, again, is the support on the operating system side. Having drivers that support multipathing, that is just happening right now, and we still don't have the first hypervisor really supporting NVMe over Fabrics yet, but we expect that to happen this year.
Our perspective is it's we're seeing interest and take up in both. Current evaluations going on for both enterprise applications as well as the hyperscale. I think that the enterprise applications are a little bit more obvious and a little bit easier to grasp. The SAS replacement or the SAN replacement that I mentioned are a little bit easier, and some of the tools are definitely an issue. Are especially lacking in the areas of orchestration for large, huge deployments within a hyperscale environment. That's going to be more disruptive. While there's interest there, I think that's going to be a longer path. So I think we'll see enterprise adoption first, and then hyperscaler probably a year or two behind, would be my guess.
Thanks. Nishant?
So actually, I have a slightly different view to this. When it comes to NVMe over Fabrics, right? If I talk to my enterprise customers, one thing is very clear with them. They understand NVMe is going to happen, A. B, they understand that they'll likely have a lot of continue to use the external storage model, right? When NVMe-based storage arrays are available, and when they are going through their compute upgrade cycles, they are investing in NVMe over Fabrics capable NICs or fiber channel HBAs. So they are not yet deploying it because there are not a whole lot of NVMe or Fabrics capable storage arrays, but they have one thing clear in their minds, that this is the path they are going to go forward with and are future-proofing their servers already. I do see, slightly different from his point here, I do see tier 2 cloud guys, and I think my definition of tier 2 cloud is anybody other than the big 5 or big 7, however you count it. I see they already deploying NVMe or Fabric. See, because the operating system challenges do not apply to them, the ecosystem challenges don't apply to them. They're all Linux shops. They have the best engineers to go hack up code and work out things for them, and I see them already deploying Fabrics to that point. Tier 1 cloud, A, I do not have much visibility into them, and B, they are mostly self-fulfilled in many ways. Okay.
Any other questions? If not, I'll take one last question. Let's do it on reverse order. Okay. So you all mentioned lack of or at least an evolving ecosystem, which is not yet complete, right? SCSI has been around forever. It runs on everything: Solaris, ESX, Windows, Linux, of course. So smart NICs are obviously exciting. Smart NICs in every server in the data center. 5 years, 50 years, or 500 years from now?
Never. See, let's understand what is a smart NIC, right? My regular couple $100 NIC, I call it a smart NIC, right? People use smart NIC as a lot of marketing term. But if smart NIC was to be better defined, we're more talking about a programmable NIC, right? Which generally has some kind of compute capability sitting right next to standard layer 2 networking and can provide you special offloads and services that you need, allow you to achieve things that is not off-the-shelf components can do. And typically that comes with high power, higher cost, and things like that. which might serve the needs of specialized customers. There are places in telco as well as tier 1 cloud, which are served by SmartNICs. But enterprise customers, tier 2 customers, most of the customers you and me talk to are extremely price sensitive. They're extremely power sensitive and would not want to deploy something that is A, not shrink wrapped, B, more than 15-20 watts, and C, costs several $1,000s. So never is my word.
I think SmartNICs they add a lot of value, and they need to be working in conjunction with some higher level tools that things like orchestration software, name services in an NVMe over Fabrics environment is a notable missing piece right now. All these need to come together. I characterize all this as kind of growing pains for this new infrastructure based on NVMe over Fabrics, but we definitely need intelligence at the host side as well as something managing everything at a higher scale.
Yeah, I think as well. I mean, if you're really looking at mass adoption, or as you said, every server, then it has to be as easy as when you pick up your phone and load an app. It's just going to be just as easy to configure your NIC. If it's not, then you're not going to have mass adoption. I think that's the reality. And we were laughing a little bit about visibility into what the big five are doing. Honestly, they control the whole stack and the hardware there. They'll make choices based on what fits them. They don't necessarily need a specific SmartNIC. So I think that's another side of it.
They're definitely more vertically integrated, as I would say.
Yeah.
Build what they need.
Yeah.
Erez.
So from our visibility today, the tier 1s will be adopting the SmartNICs in the next couple of years. We see that they are offloading not only storage IOs to the SmartNIC, but also the networking IOs from the hypervisor to the SmartNIC. Saving 4 cores means a lot of money for those hyperscalers. They could run tens more customers on the same server just because of that. In terms of enterprise, the software and orchestration and management is still missing, but we see OEMs, server OEMs looking for differentiation, and this could be key for them, and they are looking at applications such as security and storage for that. So it is happening. It will take time, and it could be for the high-end enterprise users, not for the low-end, but it's coming.
500 years?
I would say between 5 and 10.
100?
All right. Thank you very much for attending. Hope you have a nice session.